Hi, how you doing, everybody? This is 5.7 graphing linear inequalities for my intro to algebra class. All right, so the first thing was to see number one, y is greater than 3x plus 1. Now, the reason why I know it's greater than is whenever you see an inequality, it could be like this, it could be like this, it could be like this, or like this. You have to know you're not looking at where the inequality is pointing. Is it pointing left or is it pointing right? What you have to do is you have to read from where the variable is. And when I say the variable, I mean that the variable that's on the left-hand side or that's usually solved for already or alone. So we want to get it in this form, y equals mx plus b. We always want to do that. So this way we know, well, is the y greater than or is the y less than? So now I take a look at my inequality and I look at it and it says y is, now is it greater than or less than? Not because it's pointing left or right, but because the mouth of the inequality is open next to the variable. So when the mouth is open next to the variable, it's greater. If it was like this, the mouth is closed next to the variable, that means less than. I could have even switched this inequality around and said this, 3x plus 1, and if I had the same inequality and I did not flip it, I would have to read from right to left, and it would be y is closed mouth, that would mean less than, so y is less than 3x plus 1. So I have to always read from the variable. All right, so now that I established that this means greater than, I'm going to pretend for now that it's just like this, y equals mx plus b. I always need my m and I always need my b in order to graph once it's like this. And then from there, I'll know if it's dotted or solid or shaded up or shaded down. So I look here and I say, what is my slope and what is my y-intercept? Well, over here, this is where my b value is placed. So my y-intercept is positive 1. My m is 3. So if my m is 3 or my slope is 3, it really means 3 over 1. And that's going to be my change in y over my change in x. So now I'm ready to graph. I'm ready to make a graph. First thing I do is I plot my y-intercept. Let me just make this line a little bit better. Okay, a little bit better. So my y-intercept, I go up 1, I plot a point. Now from here, I use my change in y, change in x. So my change in y, here's my y-axis. So I'm going to go up 3, 1, 2, 3. And my change in x is going to be in the positive x direction. So from here, I go over 1. So now I continue that process and I go up 1, 2, 3, and then over 1 again, and I keep doing that over and over until I get my line. Now normally I would make a nice, thick, dark, solid line, but I have to concentrate on my inequality. My inequality says that it's not equal to, it's only greater than. So when I have these two symbols, I'm going to have a dotted line. When I have these two symbols with the line underneath it, it means also to include all of the values on the line. So it's going to be a solid line. And then from there, I can shade left or top or bottom. So from here, I know that I'm not going to have a solid line. It's going to be dotted. So I make my dotted line. And then if it says y is greater than means where are the higher or greater than or more positive y values. So in the y direction, that means positive or higher y values or greater than is above it, so I shade above it. Obviously, if it was less than, I would shade below it. And what this really means is it means that any x, y set of coordinates, any point within the shaded region, this could be x is negative 10, y is positive 10. So negative 10, positive 10. It would mean that if I plug in x is negative 10 and y is positive 10, what's 3 times negative 10? Negative 30. What's negative 30 plus 1? I would get negative 29 here, and positive 10 here. Is positive 10 greater than negative 29? Yes, that gives me a true statement anything in the shaded region, any point in the shaded region is going to give me a true statement. All of these points that give me a true statement, they are called solutions. So if you say, what are all the solutions of the inequality? You say all of the points that are in the shaded region and not including the dotted line or not including the points on the dotted line. If it was equal to, then all the points on the line, it would be solid, and then you can also include the points on the line. But you can't include these when it's dotted because it's not included. So it's only within the shaded region or the solid line. Okay, so number one took a while, had a lot to explain. So the others are going to go a little bit quicker as far as graphing, but as far as solving for y, it might take a little bit more time. All right, so we got 2x plus y is less than or equal to 5. Now, I always want to have my inequality in this form. Not because that's the only way I know how to graph. However, I need to know, is it shaded up or down? And I'm only going to know if it's shaded up or down if I have y alone. Because when I move things around within my inequality, this inequality sign might change. It might flip. Things might be on different sides. So I always got to get it in this form. So what I'm going to do is I'm going to over-exaggerate what I'm solving for. I'm solving for this variable. So I treat everything else like it's a number, like I'm solving a regular equation. So if I want to get rid of this, right, I want y alone. So if I want to get rid of this, I'm doing an adding or subtracting step. It's positive, so I subtract 2x. Subtract 2x. That's gone. I get y is, I did not do my special step. My special step is if I multiply or divide by a negative, that is the only time that I flip the inequality sign. So I didn't do that. I just subtracted. I didn't divide. So I leave the inequality sign the same. And I get negative 2x, and then that 5 is positive. I can't combine these together because they're not like terms. I don't get negative 10x. One has a variable, one doesn't. They're not like terms. So now from here, this is great. I have this in this form. I know what my slope is. I know what my y-intercept is, and I'm going to go and graph. Okay, I might not have the largest graph here. Hang on one second. Let me see if I can fit maybe a slightly larger graph here. Oh well, not too bad. All right, so when I take a look at my y-intercept, 1, 2, 3, 4, 5, I go up 5, I put a nice point, and then from there I'm going to use my slope. My slope is negative, make that look better, negative 2 over 1. My change in y, change in x. So from here, change in y go down 2, change in x go positive 1 in the x direction, so down 2 over 1. And then I have enough points. I only need 2 points to make a line. I can always do the opposite of this slope. I can always have positive 2 over negative 1. So up 2 and then back 1. I can always do that. And now what do I make? Do I make a solid line or a dotted line? This line underneath says include it, make it solid. So I make a solid line. Do I shade up or do I shade down? I shouldn't have pointed to over here. I should have pointed here. So now do I shade up or down? So y is closed mouth next to the variable, so that means less than means shade down. Okay, 3. (3x plus 2y), oops, 3x minus 2y. 3x minus 2y greater than 6. So again, I'm trying to solve for y. So I put a little box around the y, over-exaggerate it, and I always get rid of my term that I'm adding or subtracting to it. If I have no plus or minus in between, it means I'm multiplying, so that's the one I divide. So this is the one I'm going to add or subtract. So the sign to the left is positive. Subtract 3x. That's gone. I get negative 2y greater than, can't combine these, plus 6. And I look over here and I know I'm still solving for y. So I know no plus or minus, I'm going to have to divide. Whenever I add or subtract, it's the opposite sign. Whenever I divide, it's the same sign. So I'm going to divide everything by -2. Now this is the big special rule. Whenever you multiply or divide by a negative, you flip the inequality sign. So this little rule is something that you always have to pay attention to. You might forget it as you're in the middle of all your solving. So you cross this out now. You get y is, don't forget to flip the inequality sign. You do that. Negative divided by negative is a positive. 3 divided by 2 is 3/2. Put the x in the middle. Positive divided by negative is a negative. 6 divided by 2 is 3. All right, so now you're ready. Now you have it set up where you have your slope and you have your y-intercept, and you know what your y is. It's a positive y. You know if it's going to be solid or dotted. You know if it's going to be shaded up or down. And you go and you make your graph. So I'm going to try to make your graph a little bit bigger. Okay, so from here, my y-intercept is -3. 1, 2, 3. I put a point. My change in y, change in x. Change in y, +3. +2, 1, 2. I make a point. Do I make a solid or a dotted? Well, it's going to be a dotted because it doesn't have a line. So dotted. Do I shade up or do I shade down? Y is closed mouth next to the variable, so it means less than. So I shade below. All right, number 4. (8x less than or equal to -40). 8x less than or equal to -40. Okay, so from here, I don't have a y. I just have an x. This is a special one. If I have just an x or just a y, you just solve for that variable like you would any variable, and then it's going to be either a horizontal or a vertical solid or dotted line with some shading. So from here, I only look at the left-hand side. I'm not worrying about this negative. This negative I don't care about. I just care about, am I dividing by a positive or a negative? And in this case, I'm dividing by a positive, so I am not going to flip the inequality sign. That does not tell me to do it. This number tells me do I flip or not. So I divide, cross this out. X is, don't flip. Negative divided by a positive is a negative. 40 divided by 8 works out nice to just 5. And now I graph. So I make my line, and I try and graph. Now this means what this would mean. If it was just a line, not an inequality, then I could just say, well, this really means millions and millions and millions of points that are on a line where each and every time the x value is always going to be 5. It could be 5, 0, 1, 2, 3, 4, 5, 0. It could be 5, -1, 5, -1. It could be 5, +4, 5, 1, 2, 3, 4. So no matter what, this reminds me that, oh yeah, it's going to be a vertical line because x is always equal to 5. However, in this particular case, it's not only equal to 5, so it gets a solid line, but now it tells me that there's even more points that are going to make the solution true. So x is less than. Now, where are the less than, or where are the more negative x values? They're going to be towards the negative side. So I'm going to shade on that side. And if I were to pick any x value over here, or any point, over here, let's say this point is -5, +4. So -5, +4, I would say is negative, x is -5, y is +4. Is that going to be, oh, I just graphed this wrong. Oh, if anybody picked up on this, I graphed this wrong and made it +5. See, it's a good thing I tested it. All right, so I'm not going to correct the video. I'm just going to correct the problem right in the middle of it. 1, 2, 3, 4, 5. So -5. These all should have been -5s. My apologies. So here I make the point, and I should have had a solid line, and then everything should have been shaded this way. And if I pick any point to the left, let's say over here. And let's say this point was -8, +4. -8, +4. I can pick the x value, because there's only an x value here, and -8 is less than or equal to -5. So no matter what, any point in that shaded region or any point on this line, as long as it's equal to, it's going to be solid, will make this statement true. Okay, one mistake. And number 5. Y plus 4 is greater than 4. Okay, so I only have one variable. I'm going to solve for it. So I'm going to subtract 4. Subtract 4, that's gone. Y equals, or y is greater than. Even though I'm subtracting, just because it's a negative doesn't mean I flip the sign. I did not divide by a negative, so I just keep it the way it is. And 4 minus 4 is 0. It's not undefined or anything else. It's just greater than 0. But what does it look like? Well, I know that what this means, if it was this, it would mean that no matter what, my y value for every single point that I can think of within this line is going to have a y value of 0. So I can have 5, -5, or even 0. So I can have 1, 2, 3, 4, 5, and then y is 0. I can have 1, 2, 3, 4, 5, but y is 0. I can have x is 0 and y is 0. So now my line is going to be highlighting the x-axis. Even though it says y equals 0 highlights or is right over the x-axis. So now what I have to take into account is, what inequality do I have? I don't have a solid line. I'm going to try and over-exaggerate the dotted line by putting it over it, even though it's just slightly above it. And then y is going to be greater than, open mouth greater than, so I shade above it like this. So that means any point in here is going to give me a y value that makes this statement true. All right, that's basically it. Those are the basics for graphing inequalities. And that's it.